What if a robot could be more than just a machine? I mean, what if it could actually understand our world, find its own way through it, and even make life-saving decisions all by itself? Well, today we're going to unpack the very brain that makes all of that possible. Okay, picture this. You're in a hospital. It's that kind of controlled chaos, you know? Nurses rushing, equipment beeping, and down these long, sterile corridors, past rooms in the medicine dispensary, a delivery has to be made, and it's urgent. So the big question is, how does a single, lone robot navigate this maze, dodging people, carts, all of it, to deliver that critical medicine without a human driver anywhere in sight? Well, the answer, it's as elegant as it is complex.
The secret? It's hidden right here, inside this blueprint. This is the journey we're going to take today. And you'll see, we'll keep coming back to this exact diagram as we uncover each and every piece of the puzzle.
This is NAV2. It's the powerful open-source brain that gives robots the incredible power of autonomous navigation. I'm talking about the successor to the original ROS navigation stack, totally rebuilt for the modern world of robotics. And it's used by huge companies, from Toyota all the way to NVIDIA. It's a big deal.
All right, so how does this whole blueprint actually work? Well, the best way to think about it isn't as one single program. Nope. Think of it more like a highly specialized crew, where every single member has a critical job to do. So, let's meet them.
Okay, first up in our crew, right here, is the master strategist, the planner server. This is the high-level commander of the whole mission. So what does it do? Its job is to look at the entire map, I mean every known wall, every obstacle, and figure out the absolute most efficient path from start to finish. It's not just finding any way, it's finding the best way. It uses clever algorithms like A-star to basically solve the maze before the robot even moves an inch. Pretty cool, right?
But you know, a perfect plan, it doesn't mean much when the world is constantly changing, right? That is exactly where our next crew member comes in, the on-the-ground navigator, the controller server. So if the planner is the big-picture strategist looking at the whole map from above, the controller is the tactical officer on the ground, totally focused on what's happening in the next 5 feet. It uses a local map that's always updating so it can react in real time, expertly dodging a rolling cart or sidestepping a group of doctors that suddenly appear. Okay, but wait a minute. Who tells the planner and the controller what to do and when to do it? Well, overseeing this whole operation is the BT Navigator server. And honestly, this is the true core of NAV2.
The BT Navigator is like the conductor of an orchestra, and its sheet music is something called a behavior tree. The best way to picture it is like a really smart, really flexible checklist. It's not a rigid script. Instead, it's a tree of choices, like if the path is blocked, then recalculate, else just keep going. This whole structure is what makes NAV2 so incredibly robust and super easy to customize for pretty much any task you can think of.
And finally, watching over this whole symphony of systems, we have the Lifecycle Manager.
Just think of this one as the safety supervisor. Its whole job is to make sure every single piece starts up in exactly the right order. And what's really crucial is that if any part of the system crashes, it can safely shut everything down to prevent a total disaster. Super important.
All right, so we've met the whole crew. Now, let's see them in action. How does the robot actually get from point A to point B? It really all comes together in this beautiful 5-step dance. First, the robot figures out where it is, then it gets its goal. From there, the planner and the controller start their duet. The planner lays out that grand strategy, right? But it's the controller that improvises, moment to moment, executing the path and making those tiny adjustments until, boom, goal reached.
But hang on. All of this brilliant planning, this whole intricate dance, it all depends on one critical thing: a map. So what happens if the robot is in a place it's never, ever seen before? Where in the world does the map even come from?
Well, it has to build its own world. Yep. Before a robot can navigate a new environment, it often has to map the whole place out first.
This is done with a process called SLAM. It stands for simultaneous localization and mapping, and honestly, it's pretty much exactly what it sounds like. The robot explores a totally unknown space, figuring out where it is and drawing a map, all at the very same time.
And the SLAM toolbox is an absolute master at this. It takes in all that raw data from the robot's sensors and does this crucial task called scan matching, basically stitching new laser scans together with old ones. And here's the magic part. When it recognizes a place it's seen before, that's called loop closure, and it clicks everything into place. It's what dramatically improves the map's accuracy and turns a whole mess of data into a coherent world.
And the result? It's just remarkable. The robot starts with just a few fuzzy scans of what's right around it, and by just driving around, it turns all that fragmented data into a complete, totally navigable world, a map that it can use for every mission from then on.
Okay, so our map is built. Our navigation crew is ready. We can finally go back and solve the mystery of the hospital run.
And just like that, the mystery is solved. Using this blueprint, the planner charts the perfect course. The controller handles that chaotic hallway with all the people. The BT Navigator is there conducting the entire mission. The robot gets to the dispensary, gets a new goal for the patient's room, and completes the delivery. All on its own.
So, we've seen how this all works in a perfect world. But what happens when things go wrong? What happens when the map is out of date or when an obstacle appears way faster than the robot can react? That's when you push the system to its absolute limits. And that is our next story.
Huddy.